Okay, you might have one less template, but I'm just gonna maybe set this one up. We might not finish it, but at least set it up. So these are all different types of story problems. You're gonna see different ones today, even that are up here, but the more you kind of think about it and think of, this doesn't even make sense for the answer, I can't have a negative amount of hours, then you know you're doing something wrong or things like that. But you definitely have to be aware of how to deal with things in the real world to set up some of these. So, a student in algebra class has a test score of 64 and 78. They're not doing well, 64 and 78. What score does this person need on the third test that will give them an average of an 80? So you have to have a little bit of sense on how to find the average of three scores, right? So how do you find the average of three scores? You add up the three scores and you divide by 3. So we're going to set it up. We're going to make a bar, and we know to find the average, we divide by 3. We know we want the average to be 80 equals. We know there has to be unknowns. That's why they're called story problems, right? There's got to be something missing in a problem. That's why it's called a story problem. Again, I'll read it. A student in an algebra class has a test score of a 64 and a 78. What score must they get to get on the third test to get an average of 80? So we know the first score was 64. And you know you have to add the three scores together and divide by 3, right, to find the average. So 64 plus 78, this stands for the first score, this stands for the second score. But they don't tell us what the third score is, and we're going to use X or whatever you want. I mean, or I could use C, I could use K. We could have fun with this, right? But I'm going to use X. Probably put the 64 plus the 78 together first. 64 and 78 is 142 plus X divided by 3 equals 80. Do we get rid of the 142 by subtracting or multiplying by 3 next? Yeah, so you get 142 plus X equals 3 times 80 is 240. And then to get X alone, you subtract 142. And when you subtract 142 from 240, you get X equals a 98. Is that possible? I mean, what happens if you would have got 100 and something? It's not really possible when you know.
That means that you can't. You just can't. The test scores are so bad.
Yeah, yeah. A 98 still is pretty. I mean, that's crazy. You went from a 60. How old are you? You must be improving. That's great, right? 64 to 78. So wow, almost a perfect paper on the last one. Good job. So, I don't know if it could be possible. Okay, moving on, different types of scenarios. A clothing store is holding a clearance sale that advertises that all prices have been discounted at 20% off. If a shirt is on sale for $28, what was the pre-sale of that shirt? I'm not going to even use this formula. I like to use my own. I'm just going to put equals. The final shirt cost is what? What's the final shirt cost? Where is that going to go? Left or right? Right. And what are we trying to find? The cost of the pre-sale. Should it be more or less than 28? It should be more, right? So if you get less, then you're doing something wrong, right? So, but we're trying to find the pre-sale price, which is the letter X. We're going to put an X here. X doesn't equal 28, does it? But something before X will equal 28. There's 20% discounted off. Do you put a 0.20 next to here? Do you put a 0.80 next to there? What one would you put next to it? A 0.20 or the 0.80? You say, well, I'm 20% and 80% out of 100%, right? So would that be a 0.80 or a 0.20 would go there? And here's a good way to do it. Let's put a 0.20x and let's put a 0.8x what is it, 28? Now let's just play around with it to see which one even makes sense. To get x alone, don't you have to divide by 0.20 or divide by 0.80, right, to get x alone? So 28 divided by 0.20. 28 divided by 0.20 is x is equal to $140 for the shirt. And it was 20% off. So if it was 20% off, I'm just going to see if it makes sense to you. And if you divide, 28 divided by 0.80, you're going to get x equals $35 for the pre-sale of the shirt. Okay, if the original shirt was 140, wouldn't half be 70? Half off, right? It's not half off. It's only 20% off. So does that even make sense? That 140 would be 28? Does that even make sense? No. Does that make more sense that the shirt would be $35 and it would be 20%? So if it says that it's discounted at 20%, you don't use this number, you take 100%, take away 20%, and use the 80% number, right? So this is the answer to the problem. The original price of the shirt is $35. And before we go on to the next template, I did this with my Algebra 2 students last year. You remember me talking about this. Just showing you how to do percentages. Because some of you don't know how to do it, and maybe I'm going to help you when it's Christmas time and there's great sales. But, for example, $80. Let's say you're going to pay $80 for something. I don't know what it is. Speaker, $80. And you see that it's 10% off. You see that it's 10% off in the store. And some places have charts that tell you 20% off what the price is, what the new price is, right? But you shouldn't have to. You're in college algebra. All you do is you move the decimal over one place to the left. So what's 10% of 80? $8 off. You get $8 off. So how much would the speaker be worth now? $72. Let's say you're at Best Buy and they say the speaker is 20% off. Let's say the speaker that you want is $80, but it's 20% off. And somebody like, I can't do that. All you do is you move the place over what? One place. 10% is 80, right? Don't you just double that number? Isn't it $16 off? So if you're doing 30%, what do you have to do? Move the decimal over, figure out just what, the 10%, and multiply it by 3. 50% is really easy. I mean, if you got a pair of jeans for $120, that's what jeans are going with by, right? $120 for a pair of jeans, some people. Maybe some people even went higher, right? For all I know. Should do a survey on how much jeans cost nowadays. It's ridiculous. And they've got holes in them, right? For $120. So I won't even go there. That makes me feel old. Yeah, whatever. So $120 jeans, you walk into the store and they say that they're let's say that they're 30% off. You walk into the store and the sign says 30% all jeans, and you look at the one that you really want with all the rips all over the place, $120, and you're like, what is 30%? So all you do is you move the decimal over one place to the left. 10% is how much off? 12. What's 12 times 3? $36 off of 120. $36 off of 120. That's pretty good, isn't it? $36 off of 120. What's better though? 50% off, right? 50% off. What's even better than 50% off? I told my Algebra 2 students. Well, when would you see that? I have seen stores 75% off, 80% off. That's the highest. Yeah, 80% off. Whatever it is, buy it. Because 80% off is a really good deal. You know what I got at Target one time? 80% off. At the end of the hose is the little spigot for spraying. I got 5 of those. $1.40. $1.40 each. 5 of them. Put them in the cart. 5 of them. I told you. I know. Guess what happened? I thought I was good for a long, long time. They're plastic. They're not metal. So that when you squeeze that, after about 5 or 10 times on the hose, they completely just broke. Or they've been outside. So those 5 for $1.40. I probably should just bought one. Metal one. That's what you too. So, yeah. 75%. They were 80. I got them. I know. I still have the price tag, $1.40 for those stupid sprayers. So, anyway. So, it's fun. We have to talk about the day after Thanksgiving and who got the best deal out here. We'll have to talk about that. It'd be kind of fun to see who got it. You don't even look at the price. You just bring it up to the cash register.
It's like thrift shopping when you just like don't even have to look.
Okay, here's problem number 3. You guys can leave. It's 1:45. Problem number 3. This is a funny one. I got this out of a book. This is kind of funny, the answer to this one. So, the cost of installing some new insulation in your house. You know insulation goes bad and sometimes you have to add more insulation to your house. Did you guys know that? Yeah. Add some more for warmth, especially up in Minnesota. So, the cost of installing some more insulation in your house is going to cost you $1,080 to have somebody come in and spray some extra insulation. The present monthly cost to heat your house is $60. That's really good, by the way. This isn't Minnesota. The insulation is supposed to reduce your heating costs by 10%, you guys. That's pretty good. How many months will it take you to recover the cost of that $1,080? How many months will it take you to break even? Do you get that? So, let's just talk about this part. The present monthly cost average is $60. Let's see if you guys know what I just talked about in the last template. If the average monthly cost is $60, adding this extra insulation is supposed to save you what? 10%. So, I'm just going to move my decimal over, and it's going to save me, well, I can just do it like this too. Isn't it going to save me $6? It's going to save me $6. Every month it's going to save me $6. So, how many months will it take me to reach my 1,080? I'm saving every month $6. That's not a lot, is it? So, don't you want to get to 1,080? And isn't there going to be a 6 here because you're saving $6 every month? And you're going to multiply it by what? How many months, M? How many months it's going to take you? And 1,080 divided by 6 is 100. M stands for 180 months, which ends up being 15 years. So, I don't know. I don't know if I just put out $1,080. I would just keep your house a little colder and worse. So, I wouldn't even do that. Put on an extra sweatshirt, double sweatshirt. There you go. So this story problem's kind of funny. I just got this out of a book. I should change that to like 20% or something. Then it'll help out a little bit, right? Next year, not this year. To recover the $1,080 that you just put. 1,080 months is only 15 years. It's not many. Some of you have lived in a house. But your parents have owned it more than 15.
Yeah.
Yes.
How do you do it?
No. You know what? We should really look into ours. No. We don't have to bring that up. Hey. Okay. Here we go. The length of a rectangle is 3 times the width. The perimeter of the rectangle is 40 inches. What are the dimensions of the rectangle? This is a very basic geometry question. When it's a geometry question and ask about shapes, draw a picture, right? I always draw a picture. Let's draw a picture of a rectangle. I could talk more, but I'm kind of taping for the people that left, and it's kind of extra talk, and they don't want to listen to me talk about whatever, so I don't know about that. So, the length of a rectangle is 3 times its width. So can't we use W for the width? Does that make sense, using W for the width? And if the length of this is 3 times the width, you're not going to put W plus 3, you're going to put 3 W's. And you have to put one in terms of the other. You kind of work in one variables in this class. You don't do W and L. You work with one variable. The perimeter of the rectangle is 40 inches, so we know that's 40 inches. Perimeter is just adding these two up, which is 4W. Is that how you find the perimeter of a rectangle? What do we do? All the sides, right? So isn't there two lengths? Isn't there two widths? So 6W's plus 1W, 7W plus another W makes 8W's. So doesn't W equal 5 inches for the width? And if the width, if this stands for the width, doesn't the length 3 times as much, which is 15 inches? But when you check for reasonableness, when you add up 5 and 15, it makes 20, and you're like, wait a second, it's 40, but you need to double each of those two, right, to make the 40, which makes sense, right? Okay, now comes the harder one. And if you had me last year, we made 6-box charts, if you remember those 6-box charts. You kind of remember the 6-box charts? Kind of, so. So here we go, we have 3 of them, and I know you only have 2. I made an extra one just to set it up, to just walk you through it, because you have a bunch of these to do. You've heard of the train leaving at the same time, or a car leaving at the same time. You've heard of those story problems, right? So these are how you do these long, complicated problems, and if you follow this, it makes it easier. What I want you to do on these last 3 problems is make a 6-box chart. I think in chemistry, or when we get, if there's some chemistry problems later on in this book, chemistry takes 9 boxes because of the mixture problems of mixing different chemicals. So this is a 6-box chart, and if you're doing like a chemistry problem, you can make 9-box chart, but you're going to make a 6-box chart on your paper. Nice and big, so you can write in it. And we're going to do 3 of these, and hopefully you're going to be pretty good. And some of you are going to think, some of you think this is too time consuming, and some of you are going to think this is the greatest thing ever, because it helps me organize everything in a box, right? So, and if you follow it, every time I do all 3 of these, it's exactly the same thing. So if you just follow the exact same 3 ways I'm doing this, it's exactly the same thing. So up here above this vertical line, 100%, always you put a multiplication sign. Always. 100%. Everybody got that? 100%, there's always an equal sign right there. Always. So far, so good? This is going to change, but we have to label what we're talking about in every problem. And this one, we're talking about a car and a truck, and I don't care how you label them. I'm going to put the car here first, and the truck second. The car and the truck. So on the left is what you're talking about in your story problem, and up here, you're going to fill in the things that you're talking about, the car and the truck. And what's one thing we're talking about, cars and trucks? What's one thing we're talking about? The speed. You can either put speed, you can put miles per hour, you can put fast, you can put anything you want so that you know that this category right here stands for speed. And I'm just going to go miles per hour. I'm going to go miles per hour, and hopefully you know that that stands for speed, right? There's another thing that they're talking about in this problem. What's another thing that they're talking about? Time. Equals, total, and I know you could change it, but every time just put a total at the right. Total will always stay. It'll always say total. Cars and trucks are going to change. These 2 will change. As you can see, when we do the next 2 problems, things will change. I like the 6-box chart because I like setting it up like this. Now, these 4 boxes right here, these 4 you fill in first. Those 4 boxes you always fill in first on a 6-box chart. Everybody hear that? The first 4 boxes you fill in first. And don't we know more about miles per hour than the time that they took to overcome the truck overtakes that, right? Overtake it. So how fast is the car going? How fast is the car? So under car and under miles per hour, can't you bring these down and fill in what that is in that box? 40? Under miles per hour and under truck, can't you fill in this box? That's why I like boxes, because it fills in everything. So we filled in those two boxes, just like that. Okay, we know that the car left at 2, and we know that the truck left at 3, but we don't know how long it will take the truck to overtake the car, right? So under here, the time, there's going to be a variable under here, just like all the other problems had a variable, right? So you can put the variable any spot you want. You could put the variable here, or you can put the variable down here. It's up to you. You can choose. You have a choice. You can put it there, or you could put the x here. But if the car left at 2, which is x, and the truck at 3, do I put x minus 1 there, or do I put x plus 1 there? Is it plus 1, or is it minus 1? Do you think about life? If the car left at 2, and the truck left at 3, do you subtract 1, or do you add 1? What do you do? Subtract 1. Did he lose an hour? Didn't he lose an hour? Didn't the truck lose an hour? He didn't gain an hour. Didn't he lose an hour if he left an hour later? He lost an hour, didn't he? So underneath here, you should have x minus 1. If you want to fill it in differently, if you want to give this one the x, if you want to give the truck the x, doesn't the car have an hour on the truck? Didn't he gain an hour? And we understand that? So you could have put an x plus 1 up here, but we're going to leave it the way you guys have it like this. Don't you have it like that? Okay. Questions on how to fill in the first 4 boxes. So how do you get these other 2 boxes? Some of you remember this from last year, right? How to get those other 2 boxes. How do we get these 2 boxes? You take this times this equals that. So you just take this times this, and you fill it into over here. You're going to have 40 times x. That's how you fill in that box. You look at those boxes that you already filled in. How do you multiply 60 times x minus 1? 60x minus 60. It's just the distributive property. I just don't have parentheses around it to show it, but it's distributive, right? See, now what do you do with those 2 green? Those 2? These 2 are the only ones that you use to set up your story problem. That's why you make a 6-box chart. So maybe you want to bubble them in, maybe you don't, but you're either going to do 2 things. You're either going to set these 2 equal to each other to help you work out the problem. They're either going to be set equal to each other, and if I were you, I'd put that so you know what to do when you do 6-box charts. Or you're going to take these last 2 and add them together and set them equal to a total. You're going to set them equal to a total. So we have to decide, is it this type of the problem, the first one, or is it the second way? So let's just look up there. We already kind of used the 2 and the 3. We kind of already used the 40 and the 60. There really isn't anything else to use. It doesn't say they want a total distance, right? It didn't say total distance. So we're not going to do this one. We're going to set these 2 equal to each other. These 2 boxes equal to each other. So you're going to have 40 x's equals 60 x's minus 60. You're going to set them equal to each other. You can bring the 60 over to join the 40, and when you bring the 60 over to join the 40, isn't that going to be a negative 20 x's? You're going to have a negative 20x equals a negative 60. Divide both sides by a negative 20, and x equals 3 hours. But then you kind of have to answer the question. That's the hard part in this book, too. They're going to ask you a question that you have to answer on the test. We just got to x equals 3, right? Let's answer the question. How long will it take the truck to overtake the car? How long will it take the truck to overtake the car? You can say 3 hours, right? Isn't 3, x equals 3. Or you could say the time. What time will the truck take to overtake the car? At what time will it take? What time exactly will the truck overtake the car? No. No. 5 p.m. Okay, let's look at this. Let's look at this. You could get it wrong. So, what does X stand for? In your chart, that's why we made a chart, right? Let's look at the chart. What does the X stand for? Car, okay? So if we're looking at the car, and doesn't X stand for 3, what's the car time? What time did the car leave at? 2, and what's 2 plus 3? 5 p.m. But maybe you don't want to do the car, we want to talk about the truck. Isn't that the question? When will the truck overtake the car? So let's now look at the truck. Well, isn't this the truck? Let's look over at the truck, and what does it say for truck? X minus 1. What's 3 take away 1? 2. So now we have 2 in there, right? What do you do with that number 2? Add it to what? At the time the truck left, what's 3 plus 2? 5 p.m. again, right? Isn't it 5 p.m.? So you got to make sure that you read the chart and understand how the chart works. That's why the chart is there. Got it? Everybody got it? Some of you are like, this is stupid, I don't like the chart. And some of you are like, I totally understand how to set up the chart. But maybe after a couple more, you'll understand how to set up the chart. So here's another 6-box chart, and then another 6-box chart, and we'll be done here. You don't have to make it as big as mine, but I know. I got this out of an old book. I got this out of an old book, and it says, in the concession stand, they sold a slice of pizza for 75 cents and a hamburger for $1.35. They sold 40 more slices of pizza than hamburgers, and they sold a total of $292.50 worth of hamburgers and pizza. How many of each were sold? So, make a 6-box chart. 100%, you always put a multiplication sign right there, right? 100%, you always put an equal sign right there. And 100%, there's always a total right there. And if you set this up every time, you should do pretty good when you start doing those 6-box charts. There's a bunch of them. 1, 2, 3, 4, 5 of them for tomorrow. So, again, they're not talking about trucks and cars anymore. We're talking about pizza and I'm just going to put ham for hamburger. And some of you are like, this is really cool. I wish I would have known how to do this. And some of you are like, I could solve this way faster than what she's doing, but it is what it is. Okay, up here was the speed and the time of a car and a truck. We're not talking about speed and time anymore, but we are talking about, what's one thing we're talking about? How much, price, can we just put a dollar sign? You can you can put how much, you can put amount, you can put price, you can make a dollar sign, whatever floats your boat, that you understand that this column right here will stand for the pizza and the price and the hamburger and the price. And there's one more thing that we're talking about. How many? And I'm just going to make a number sign. Is it easy to set it up every time? Okay, now comes this part. You always fill in those 4 boxes first. Always, in a 6-box chart. One of them you're kind of iffy on, and the other one you really know what's going on, right? Aren't you kind of iffy on one of these two? Either the price or the number. One of those you're iffy about, aren't you? But you really know the what? The price. So what is it? 75 cents and $1.35. You always will know 2 out of the 4. And now comes the iffy part. They sold 40 more slices of pizza than hamburgers. They sold 40 more slices of pizza than hamburgers. Where is this X going to be located? Under the pizza or under the hamburger? Does it really matter? It really doesn't matter, but I'm going to put it in the hamburger. And if you sold 40 more pizzas than hamburger, you're going to put X plus 40 up there, right? Was that easy to set it up? And then, some of you will have no clue where to come up with these 2 boxes. And if you ask somebody next to you, they're going to say, what are they going to say to come up with these last 2 boxes? The person next to you is going to say, just multiply these 2 boxes across. That's how you come up with those boxes over there. So you're going to get 0.75x plus 30 and 1.35x's. That's how you fill in those boxes. So far, so good. Then, I said, you only use these 2 boxes. You either set them equal to each other like that, or you add up these boxes that are there and set them equal to some total. Well, we haven't talked about one thing up there, haven't we? We haven't talked about $292.50. We haven't talked about that at all yet. It's not shown anywhere in our problem, is it? $292.50. So, do we set those two boxes equal to each other or add them up on the same side? Same side. Yep. 0.75x plus 30 plus 1.35x equals 292.50. Ran out of room. I'll put my x's together. 1.35x's plus 0.75x is 2.1x plus 30 equals 292.50. Subtract 30 to get 2.1x equals 262.50. So you subtract 30 from 292.50. Divide both sides by 2.1 and get to there. X equals 125. But when you're done with your problem, you have to go back up and make sure you answer the question, right? Let's see what they're asking us to do. They're asking us how many of each were sold, so we have to find how many of each were sold. So we have to answer that question. Again, that chart helps you. I found that x equals 125. I go back up there and I look at x. I look at the, oh, that's what does that stand for? Hamburgers. Well, that's easy. I just have to add 40 to my, the 125, which makes 165 is how many pizzas that were sold. So looking at your box helps you solve the problem. I know you don't have this last one. I just want you to help me set it up and I'll let you loose. So, let's see if you guys can, this is a more complicated one, and if you can do this one, you can do any one. This is like problem 38 or something, or 40 in the book. So if you can do this one, you can do a 5 or 8 or whatever the problem is. Some salesperson purchased a car that was advertised as averaging 25 miles to the gallon in the city, and this is wonderful. You would like to get a car like this. 40 miles to the gallon on the highway, that's really good. But the cars do have that. There's some cars, not many. A recent sales trip covered up 1,800 miles and it required 51 gallons of gasoline. How many miles were driven in the city? So you know that there are how many miles driven altogether? 1,800, right? So this looks really, doesn't it seem really complicated? Like I don't even know where to start. So what are you going to do when you read this? Make a box. Make a box. And 100%, you put a multiplication sign, you put an equal sign, you put a total. And we can finish it, we can set it up, it's up to you. I didn't even, I ran out of time with the other hours, so. Are we talking about a car 1 and car 2? Are we talking car 1 and car 2? Are we talking about 2 cars up here? We're talking about specifically city and highway miles, yes. City and highway. Can you set this up? Easily you can set this up, right? You can easily set this up. What's one thing we're talking about in this problem? Miles per hour. Can you easily set this up by yourself? You should be able to do this. Okay, how many miles were driven in the city? That's what we're trying to find. But altogether, there was 51 gallons of gasoline used. We don't know how many gallons were used in the city and in the highway, right? But you get miles per, well, it's miles per hour, but miles per gallon. So what are you going to put right here? What do you think has to go there? Miles or the gallons? Gallons, yeah. Gallons, I'll just put gallons. Like that. So far, so good? Okay, let's see. We always fill in, how did it do this? We always fill in the red. Of these 4, there's going to be 2 that are automatically, you can just fill in with numbers, right? You know which one that you can? If you're sitting all by yourself, do you know which 2 that needs to be filled in? Okay, so if you're sitting by yourself, the 25 miles per, this is miles per gallon, not miles per hour, sorry you guys. is 25, and highway is 40? 25 and 40? Okay, let's talk about the 51 gallons. Ready to talk about the 51 gallons? I wish it was 50. I wish it was an easier number, but one of those has to be the X, correct? Doesn't matter which one is the X. Have we talked about it? Really doesn't make a difference which one is the X, right? Which one do you want it to be? That one or that one? Up. Okay. There are 51 gallons of gasoline you used altogether in the city and in the highway, correct? You used a certain amount of those in there, right? Right? So let's see if you guys can figure out what some of you already know what can go here, right? Let's say you use 20 of it, of the 51 here. If you use 20, how many would you have used here? 31, right? You would have used 31. But we don't know what this number is. That's why it's a what? X. What happens if you only use 10 of those? How many are left here? 41. What happens if you only used one of those in here? How much would have been here? We don't know what X is. Do I keep changing X? Isn't X called a variable for a reason? Because a variable always what? Variable means it changes, right? So I keep coming up with a different number right here, don't I? 1, 10, 20, or whatever I want. But if this changes, how did I get this? How did you do that in your head to come up with those other numbers for highway? What did you do in your head to come up with those numbers? 51 minus X. Yep. You see what I'm trying to make your mind do? You did 51 minus X in your head, right? X kept changing, right? Why not this way, you guys? Why not this way? Some of you are going to write it like this, and some of you are going to write it like this. Some of you are going to write it like this. Let's think about it. If X was 1 gallon, is everybody thinking of 1 gallon right now? If there's 1 gallon here, what happens if you put 1 minus 51 here? What's 1 take away 51? A negative 50 gallons. Does that even make sense? A negative 50 gallons of something? Do you see why it has to be written using it that way? Okay, how do you get these two if you just walked in the door and you have to explain it to somebody? How do you get those two? You multiply them across, and I didn't finish this, so this is 25 x's. That's 40 times 51, 2040 minus 40 x's. Everybody see where we got that from? Okay, now these two boxes are the only two that you use to set up. I mean, I think you're getting pretty good at this by now, right? Getting pretty good at this. Is there a total that we haven't even used yet, or do we set these two equal to each other? There's a total. So what are you going to do with those two boxes? Add them up and set them equal to, should we finish it? I will finish it, right? 25x plus 2040 minus 40x equals 1800. 25x plus 2040 minus 40x equals 1800. And then you're working it out and you add these two together and you're going to raise your hand and say, oh my gosh, Miss Cho, so I've got 25x take away 40x. I'm going to have a negative 15 something. So you got to keep working the problem out, because if this is a negative 15 plus 2040 equals 1800, when you bring that guy over to the other side, that's also going to be a negative, right? So then the negatives will end up being, cancels out, right? So I don't know, what is 2040 take away 1800 is 240. 15x equals 240, because two negatives equal a positive, so I cancel it out. 40 divided by 15 is 16. 16 equals what? What is 16 equals if you look at the chart? Gallons. But what's the question asking? How many miles were driven in the city, you guys? Do they want that on the test as the answer? Do they want 16 gallons? Is that how many miles were driven in the city? 16 gallons? How many miles were driven in the city? Where do you have to look to get the answer? First of all, you have to look under city, right? Do we have to look under miles per gallon? The gallons, or the total when you take the miles per gallon and multiply it by the gallons? Don't you have to do 25 times 16? Which is 400. 400 of those miles. 400 of the miles were driven in the city. Well, obviously, the other 1,400 were driven on the highway, right? They didn't ask that question. They only asked. So, even though you get the answer, doesn't mean on the answer key that that's the answer, because you have to answer what they ask you to. So, okay, that's about it. I'm going to pass out the answer key.